We covered data types and collections in part 1 and pattern matching with control flow in part 2. If you haven't watched those, go start there. In this video, we are tracking functions, both anonymous and named, and one of Elixir's most beloved features, the pipe operator. So don't waste our time and let's get into it. Elixir has two kinds of functions. Let's start with anonymous functions, functions with no name, defined on the fly. You define them with fn and end with the arrow separating the parameters from the body. Notice the dot before the parenthesis when calling it. That dot is how Elixir distinguishes calling an anonymous function from calling a named one. Because anonymous functions are used so often, Elixir has a shorthand using end symbol. Anonymous functions also support pattern matching. You can define multiple clauses and Elixir picks the first one that matches. Named functions live inside a module. Think of a module as a container, a way to group related functions together. You define one with def module and functions inside it with def. For short single-line functions, there is a compact form. Same result, fewer lines. You will see both styles in real Elixir code. One important concept: in Elixir, a function is defined by both its name and its arity, the number of arguments it takes. So these three functions are completely different, even though they share a name. This is not overloading. Each is its own function. Elixir picks the right one based on how many arguments you pass. Alright, the pipe operator. This is one of those features that once you use it, you wonder how you ever live without it. The problem it solves: deeply nested function calls are hard to read. Imagine this. You have to read it inside out to understand what's happening. The pipe operator lets you write it left to right. Instead, it takes the result of one expression and passes it as the first argument to the next. Same logic, but now you read it in the order it actually executes. Here is a real example with strings. Step 1, uppercase the string. Step 2, split into words. Each result flows into the next function. It reads like a recipe. Now let's talk about comprehensions, a clean, expressive way to transform collections. You have already seen enum.map. Comprehensions do something similar but with a different syntax. Here's the basic shape. You can also filter inside a comprehension, just add a condition after the generator and only values that pass will be included. That's equivalent to enum.filter followed by enum.map in one line. Comprehensions give you a readable alternative to enum.map and enum.filter when you want to transform or filter a collection in a single expression. A good rule of thumb: reach for comprehensions when your transformation is simple and self-contained. For more complex pipelines, stick with enum and the pipe operator.